Let's see how many times you say hello to Minky and hello to Chinky. You say hello to Chinky 2 times and hello to Minky 4 times. I'm telling you, Chinky will kill you. Hello everyone, welcome back to the series of Complete Python, specifically designed for great data science and artificial intelligence. In this session, we will discuss about the various set operations. There are many popular set operations like union, difference, symmetric difference, intersection, containment, comparison. Many operations are there. Let's perform all these operations over the set in this session. Let's go to the Jupyter notebook and apply all these operations on the set. Let me make the heading over here. Fine, okay. So let apply containment, comparison, union, intersection, difference and symmetric difference, all these operations over the set. Starting with the containment operation. Let me make the heading for containment operation. So containment operations just check if an element is present inside the set or not. That's it. So let me take one example set over here and apply the containment operations over that. So there are two different type of containment operators which can help us to check if an element is present inside the set or not. These are actually in and not in. We have used it earlier also. So in will help us to find out if an element is present, this will return true if element is present. If and not in will return true if element is not present inside the set. Let me write a if statement over here to apply these two containment operators over the set. So let's try to find out, is the A present in set 1? So if that is present, we can print something. We can print hello, how are you? Otherwise, we can print go to hell. Fine, okay. If I will execute this statement, then we are printing hello, how are you? We are printing this statement, executing this statement because A is present inside the set. Yes, in is checking is this string is present inside the set or not. Yes, that is present in set 1. A is present in set 1. Let me apply the not in operation now. Let me copy this code. Copy paste is a nice feature that reduces our burden. So let me check if A not in set 1. If A not in set 1, then we will execute this statement, otherwise we will execute this statement. In this case, actually this statement will fail because A is present inside the set. Okay, so this statement will fail. So if I will execute it, you can see over here we need to go to hell because A is present and we are saying that A not in set 1. Okay, fine, okay. So these are the two containment operations we can perform over the set to check if the particular element is present inside the set or not. That's it. That's it. Now let's perform other operation, that is comparison operation on the set. So there are many comparison operation. Let me make the heading and perform all these comparison operations. Okay, so let me take some sample sets on which we can apply the comparison operations. So we have 4 sample set over here. Set 1 having element 1 to 4, set 2 is having element 1 to 3 and then 5, and this also having 1 to 4 elements, and this is having 1 to 3 elements. And we have different type of comparison operations like equivalent, subset, superset, proper subset, proper superset. Okay, we can apply all of them one by one on these sets. Okay, fine. Let me start with the equivalent operation. Let me make the heading over here. So let me write a if statement. if S1 is equal to S2, then okay, let me print hello Chinky. We can say hello to Chinky if this statement is true. We can let me write one more if statement. If S1 is equal to S3, then okay, let's say hello to Minky. Let me say hello to Minky. Let me execute this code and see what will happen. So we are saying hello to Minky. Why we are saying hello to Minky? Because S1 set is same as S3 set. You can notice over here all the elements in S1 and S3 are same. So two sets are same, equivalent if every element is matching between these two sets. Okay, so here every element is matching between S1 and S3. That's why this statement become true. Why we are not saying hello to Chinky? Because S1 and S2 are not same. See here 1 to 3 elements are matching between S1 and S3, S1 and S2, but this 4 and this 5 is not matching. So even a single element is not matching between two sets, then set are not equivalent. Fine, okay. So we understand, okay, that okay, S1 and S3 are equivalent, but S1 and S2 are not equivalent. Now let me use another operator, that is not equivalent operator. Make the heading. Let me copy this code itself and paste it over here and replace the operator with not equal to. Not equal to, not equal to, and if I execute it, let's see what will be the output. If I execute it, this time we are saying hello to Chinky. Why we are saying hello to Chinky? Because S1 and S2 are not equivalent. So even a single element is not matching. Yes, here 4 and here 5 is not matching with each other. So they are not equivalent. Yes, this condition satisfy. So we are saying hello to Chinky. But S1 and S3 are equivalent actually. This statement is saying they are not equivalent. They are equivalent. Every element is matching between S1 and S3. So this is false. So that's why we are not saying hello to Minky. Fine, okay, these are the two comparison operations we perform. Another one is the subset operation. So let me make the heading over here. Let me copy this code over here. Fine, okay, let me copy these sets also so that we can check out our results. I'm copying that set downside. And okay, let me make little modification in this code. And first of all, let me replace this operator. This should be less than equal to. Here also less than equal to. Let me make little changes in the here also. Okay, let me put it 4 over here. Let me put 4 over here and now execute the code. This time we are saying hello to Minky. Why we are saying hello to Minky? Why we are saying hello to Minky? So let's see. S4 is the subset of S3. That should be subset of S3. S4 is the subset of S3. Yes, all the elements of S4 are present in S3. Yes, all the elements of S4 are present in S3. That's why S4 is the subset of S3. What about this statement? Why we are not saying hello to Chinky? S1 is not a subset of S2. S1 is not subset of S2. Why? Because all the element of S1 is not present inside S2. All the element of S1 is not present inside the S2. That's why S1 is not the subset of S2. Fine. Fine, okay. Now let me apply another operation, that is proper subset operation. Proper subset. Making the heading. Taking this code itself over here, and because we are finding proper subset, so equal to will not be there. Okay, equal to will not be there. Proper subset mean is that Set cannot be equal. Set cannot be equal. Okay. Here in the case of subset, set can be equal also. Okay. So here I can say that S1 is subset of S3. S1 is subset of S3 because every element of S1 is present in S3. So S1 is subset of S3, but S1 is not proper subset of S3. S1 is not proper subset of S3 because equivalent is not present over here. Equivalent is not present in the case of proper subset. So S1 and S3 are not proper subset. S1 is not proper subset of S3. And okay, let me make some more changes over here. Let me make S3 over here. And can you tell me what should be the output now? This time you can pause the screen and you can try it. Let's see to whom we are saying hello this time, either to Chinky or Minky. This time we are saying hello to Minky. Why we are saying hello to Minky? Because S4 is proper subset of S3. Yes, all the elements of S4 are present in S3. One thing is this. Another thing is that both these sets are not equal to each other. They are not equal to each other. See, here only we have 3 elements, here we have 4 elements. So they are not equal also. Equal to is also not there. But still all the elements of S4 are present over here. So this is the proper subset. S4 is the proper subset of S3. Simple. Proper subset means that should be a subset, but that should not be equal. Number of elements should not be equal. Okay. Fine. Okay. So this is about the proper subset. Now let's apply the another operation, that is superset. Let me take this first, these sets downside, and now making the heading for superset. Let me take this code itself from here, changing the operation. So superset operation is greater than equal to, that is greater than equal to. Fine. Okay, let me execute this code and let's see what should be the output. Again, you can pause the screen and you can try it at your end. To whom you want to say hello? Let's see to whom we are saying hello. We are saying hello to Chinky. We are saying hello to Chinky this time. Why we are saying hello to Chinky? Because S1 is superset of S3. S1, you can see S1 is superset of S3. All the element of S3 are present in S1. All the element of S3 are present in S1. Equal to is also allowed. So elements are equal and all elements are same. So yes, S1 is superset of S3. Okay. But why we are not printing hello Minky? Because S4 do not contain all the elements of S3. S4 do not contain 4. Okay. So S4 do not contain all the element of S3. So that's why we are not printing hello Minky over here. Fine. Okay. Now let me apply another operation, that is proper superset operation. Let me make the heading. So let me take this code and changing the symbol. Okay, equal to should not be there in proper superset. Okay, equal to should not be there. And okay, I'm changing the sets also to understand proper superset properly. So okay, I change this to S3 and this set to S4. If I'm executing it, so let's see what should be the output over here. The output here is we are saying hello to Minky. Why we are saying hello to Minky? Because let's see, because S3 contain all the elements of S4. Yes, S3 contain all the elements of S4. So S3 is the superset of S4, and that is proper superset because the number of elements in S3 more than the S4. They are not equal. Okay. So to be proper superset, number of elements should not be same. Equal to is not here. Equal to is not here. But still S3 must contain all the elements which are present in S4 to be its superset. Yes, that's why we are saying hello to Minky. Why not printing hello Chinky? because S1 contain, here you can see S1 contain all the elements of S3. Yes, S1 contain all the elements of S3, but they are equal also. Equal to is not allowed in case of proper superset. Proper when come, then equal is not allowed. Fine, okay. Now let's see, okay, let's see how many times you say hello to Minky and hello to Chinky. You say hello to Chinky 2 times and hello to Minky 4 times. I'm telling you, Chinky will kill you. Okay, fine, okay, let's move on. Now let's apply the union operation on the set. Union operation will join the two sets without allowing the duplicates. Actually, that will take all the elements of first set and those elements of second set which are not present in first set. So, okay, let me take one example and show you over here. First, let me make the heading. Let me take some sample sets over here on which we can perform the union operation. So, we have taken 3 sets. Set 1 is having element from 1 to 5, set 2 is having element from 3 to 7 and set 3 is having some strings ABC and some numbers 1 to 4. So, let us perform union operation over here. So, let me create a new set, set 4 by performing union operation on set 1 and set 2. So, we can perform union operation by this union symbol. This symbol is also used for bitwise OR operator. So, by using operator overloading, we can use the same operator for multiple operations. So, here we are using this operator for union. Fine, okay. So, let us union these 2 sets and let me print set 4. So, if I am executing it, we can see that we have taken all the elements of set 1, 1, 2, 3, 4, 5, yes, and those elements of set 2 which are not present in set 1, yes, 6 and 7 is not present over here, but 3, 4 and 5, these are present, so we don't take those. So, this is how we take the union. You can say in other words also, union joins the item in 2 sets without duplicates. So, here you can see that 3, 4, 5 is present here also in set 1 and in set 2 also that is present. So, we will not repeat them, duplicate is not allowed, only one time we are taking 3, 4, 5, otherwise taking all the elements of set 1 and set 2. Fine, okay, so this is how we take the union. We can take the union by using the union function also. So, let me apply over that, creating another set, set 5. So, set 1 dot union with set 2. So, by using this union method function, we can also union 2 sets. So, here we are making union of set 1 and set 2. So, let me print set 5. So, if I execute it, yes, we are getting the same result what we were getting earlier by using this union operator. The same result we are getting with union function. We are just making the union of set 1 and set 2 over here. We can union multiple sets also. Okay, so let me make the heading over here. Simply what I need to write, I can create a new set, okay, set 6 by taking the union of multiple sets, set 1, set 2, set 3. So, taking 3 sets, okay, and taking union of these 3 sets, and I am printing the set 6 over here. So, we take the union of multiple sets, that is it. So, by just writing this symbol multiple time, we can take any number of set union altogether. So, here we take the union of these 3 sets. You can see that, okay, we take all the element of set 1, yes, and 6, 3, 4, 5 was already present, so we don't take again. 6, 7 was not present in any of the sets, so we take 6, 7. 1, 2, 3, 4, 5, 1, 2, 3, 4 was already taken over here, so we will not repeat that, duplicates are not allowed. So, ABC was not present, we take that A, B and C. The order can be changed because set are unordered, okay. Fine, okay, so we take the union of multiple sets. We can take the union of multiple sets by using union function also. So let me copy this code and paste over here and create a new set. Okay, set 7, print the set 7, and I'm making union with set 2 and set 3. So passing multiple sets now inside this function and making union of it with set 1. So if I will execute it, this time again you can see that, okay, we take the union of set 1, set 2, set 3, and which is same as what previously we get. Fine, okay, so this way we can take the union of multiple sets also. We can take the union with list and tuple also. We can union this set with list and tuple also. So let me show you. Let me take some sample tuple and list to show you that, okay, we can take the union with the tuple and list. Fine, okay, here we have a new set A, we have a tuple B, we have a list C. So we will try to make the union of this set with this tuple and with this list. Fine, okay, so simply what I can do, I can write, let me create a new set. D is equal to set A dot union with B. B is the tuple. So we here union our set A with the tuple. Okay, fine, and I can union this set A with the list also. So list is C, I am passing C over here. Even I can union with both of them. So F equal to A dot union B comma C. So let me print, okay, let me print these new sets, set D, set E and set F. So if I print them, we can see over here that, okay, we get, this was our set over here x, y, z, x, y and z, that union with the tuple 1, 2, 3, yes, we tuple union and set by using this statement. We make the union of list 4, 5, 6, you can see over here 4, 5, 6 with the set x, y, z, and we union all of these three, yes, all of these three are union over here. So yes, we can make the union with the tuple and with the list also by using this union function. We cannot make the union of tuple and list with set by using this operator. Okay, this operator cannot be used to take the union with the set with the list and tuple. Okay, so list and tuple can be union only with the help of this union function. Fine, okay, now let's perform other operation on the set, that is intersection. Intersection will take the common element between the two sets. Okay, let me take the example and show you how intersection operation works. So let me make the heading first. I am taking some sample set with me. So we have three sets with us, set 1, set 2, set 3, set 1 having element 1 to 5, set 2 is having 3 to 7 and set 3 is having some strings and some digits. Fine, okay, let me apply the intersection operation on these sets. I am creating a new set 4, applying the set 1 intersection set 2. So whatever element will be common between set 1 and set 2, that will be get stored into this set 4. Let me print set 4 over here, and if I execute it, you can see that the common element between set 1 and set 2 is 3, 4, 5. Yes, so intersection is finding the common element between two sets, and here we are using this symbol for the intersection. This symbol is also used for bitwise AND, but again by operator overloading we can use one operator for multiple operations. So here we are using it for intersection of two sets. We can perform intersection by intersection method also. So let me perform that, creating a new set 5 and performing the intersection between set 1 and set 2. So simply using the intersection function and in this passing the second set, set 2. That's it. So here we perform intersection between set 1 and set 2. Simply we need to write set 1 dot intersection function, and in this we are passing set 2. That's it. If I print the set 5 over here, so we are getting the same result what we were getting earlier. So let me execute it. Yes, 3, 4, 5 we are getting, because in set 1 and set 2 these are the 3 elements which are common. We can take the intersection of multiple sets also. Let me make the heading over here. So that is very easy to take the intersection of multiple sets. Simply what I need to write, I will create a new set, set 6. I will take the set 1 intersection, set 2 intersection, set 3, that's it. I can write any number of sets over here. Done. So if I print it, so whatever will be common between these 3 sets, that will be printed. So let me execute it. So the common between these 3 sets is 3 and 4. 3, 4 is here also, and in set 1 also. So 3, 4 will be printed. We can take the intersection of multiple sets by using this intersection function also. Let me show you, creating a new set 7. So set 1 dot intersection, passing 2 sets, set 2 and set 3. You can pass any number of sets. I am printing it. Executing it. Yes. So intersection of these 3 sets, set 1, set 2, set 3 is 3 and 4. 3 and 4 are the 2 elements which are common between set 1, set 2 and set 3. Fine, okay. One more thing I can show over here is that, okay, rather than creating a new set over here, I can perform this operation, intersection operation, in place also. Means don't need to store it in a separate set. This will be updated in set 1 itself. Okay, let me show you how. For that I need to use another function. So I will use the function of intersection update, intersection underscore update. So this will update set 1 itself. Whatever will be common between set 1, set 2 and set 3, that will be updated. Final result will be updated in set 1 itself. So if I will print the set 1 now, then you can see still that will be 3 and 4. Yes, that is 3 and 4. So in place we perform the intersection. We do not create a new set to store whatever is the intersection between the sets. We just perform the in place operation. So this is, okay, various operations we perform with respect to the intersection. Okay, now let's perform the difference operation on the set. Difference operation, find out the difference between 2 sets. That's it. Okay, let me apply it over here. First of all, let me make the heading. I'm taking some sample sets over here on which we will apply the difference operation. So these are the same set which we have taken already earlier also. So I'm finding a difference between set 1 and set 2. So whatever difference will come, I will store it into set 4. Set 1 minus set 2. So minus operator is also used as a difference operator. Okay, so it's finding the difference between set 1 and set 2. And I'm printing now set 4. So if we execute it, we can see that, okay, difference between set 1 and set 2 is 1 and 2. So here you can see that difference means you are deleting the elements which are available in set 2 from the set 1. Okay, so here 3, 4, 5 are available in set 2, you are deleting it from set 1. So whatever is left in set 1, that is the difference between set 1 and set 2. So simply you can take it like, okay, you're taking the element of set 1 and whatever element is repeating in set 2, you're deleting those elements from set 1. That's it. That is the difference between set 1 and set 2. We can find out the difference with the help of difference function also. So let me find it and create another set 5. So set 1 dot difference. As an argument I am passing set 2. That's it. So this is how we can apply the difference function to find the difference between set 1 and set 2. Let me print this set 5 now. Same output you are getting. So this is the difference between set 1 and set 2. You can find the difference with the difference function also. We can find the difference of multiple sets also. Okay, so let me make the heading first. Creating a new set 6 by taking the difference between set 1 minus set 2 minus set 3. So this will find the difference first between set 1 and set 2. Whatever will be left, then from that you are subtracting set 3 elements. Okay, so if I am executing it, before that, okay, let me print S6 set 6, and if I am executing it, you can see that we left with empty set actually, because if we are subtracting set 1 minus set 2 we are performing, then 1 and 2 will be left, and 1 and 2 will be deleted due to this 1 and 2 in set 3. So empty set will be left with. Okay, we can perform multiple set difference by using this difference function also. So let me copy this from here and paste it over here, creating a new set 7, printing this itself set 7, and now passing multiple sets set 2 and set 3. So if I will execute, I will get the empty set again, because if you will take the difference, then you will get the empty set, nothing will be left. We can perform the difference operation in place itself also. Okay, in place. How? So rather than whatever result we are receiving from this function, we are storing it into a new set, but we can update our this set 1 itself. Okay, how? Simply write set 1 dot function name. Function name this time is difference underscore update. So this will update the set 1 itself. So if I am finding the difference with set 2 only, and if I am printing now set 1, so set 1 must have element 1 and 2 only. Okay, so let me execute. Yes, set 1 only have element 1, 2. So in place we perform this function, means I just find the difference between set 1 and set 2 and store the result back into set 1. So this can be done with the help of difference underscore update function. One more operation, okay, I can perform over here is that I can find the difference of a set with a list and difference between a set and a tuple also. Okay, so let me take some sample set, tuple and list over here to find the difference between them. Okay, here is our new set with us, and this is the tuple we have. B is the tuple and C is the list over here. So let's find the difference between this set and tuple first. So what I need to do, simple. So I'm creating a new set which we will get after finding the difference between A and B. So A dot difference, with B we are finding the difference. Okay, so B is a tuple over here. Similar way we can find the difference of a set A with the list also by using this difference function. So list is C, that's it. So if I print both of them, D and E. So let me print, and yes, the difference between this set and this tuple is 4, 5, 6. So yes, we are getting 4, 5, 6 over here. difference between A, this set, and this list, which we are finding with the help of this statement, is actually 1 2 3. Yes, we are getting 1 2 3. So yes, we can find the difference between a set and tuple also, and set and list also. Note down, we cannot use this minus operator, this operator, to find out the difference between a set and tuple and set and list. We cannot use this operator. We can use only the function for this operation. Okay, fine. Okay, now let's apply the another operation, that is symmetric difference. Symmetric difference, if you are taking of two sets, you will find out all the elements of these two sets except those which are common between them. So let me show you with one example over here. Before that, okay, let me make the heading. So let me take some sample set over here. So these are our same sample set we are using. Now let me take a symmetric difference between set 1 and set 2 and creating another set, set 4. So here we find out the symmetric difference between set 1 and set 2, and you can notice here is that take all the elements of set 1 and set 2 except those which are common between them. So 3, 4, 5 is common between set 1 and set 2. So we do not consider 3, 4, 5, otherwise we take 1 and 2, yes, and 6 and 7 from set 2. So take all the elements of both the sets except which are common between them. That is the symmetric difference between two sets. And we use this XOR operator, or you can see if you know about the XOR operator, we use this bitwise XOR operator as a symmetric difference operator. Again, Python is performing operator overloading to perform two different tasks with the same operator. So okay, this is the operator we are using for symmetric difference. We can use the symmetric difference function also to find out the symmetric difference of two sets. So let me apply that function over here. Set 1 dot symmetric difference function, symmetric. In the parameter I am passing set 2. That's it. So let me print now set 5. If I execute it, I am getting the same result because I am taking the symmetric difference of set 1 and set 2 again with the help of this symmetric difference function. We can find out the symmetric difference of multiple sets also. Okay, so let me make the heading first. So simply what I need to do, I just need to put multiple sets over here with the symmetric operator. Set 1, set 2, symmetric operator set 3. Okay, I can put any number of symmetric operator and put any number of sets over here. So how this will work? First this will take the symmetric difference of set 1 and set 2, then whatever result will come, that result symmetric difference will be taken with set 3, and so on. This will go on. Let me print now set 5. So if I execute it, I find out that okay, the symmetric difference between set 1 and set 2 is actually 1, 2, 6, 7. This is the symmetric difference. If I am taking this and this set difference, so you can see that what is common between this and this set is 1, 2 is the only common. So remove 1, 2 and include everything. So ABC is there, 3, 4 is there, you can see. ABC is there, 3, 4 is there, 6, 7 is also there because 6, 7 is not here. Fine, okay. So we can take the symmetric difference of multiple sets also. I can use this symmetric difference function also to find out the symmetric difference of multiple sets. Let me take this. I'm not sure, I think I cannot use this function to perform. Yes, actually this function cannot be used to find out the symmetric difference of multiple sets. Okay, we need to use this operator only to find out the symmetric difference of multiple sets. Okay, so this cannot be applied. This cannot be applied in the case of symmetric difference. But we can apply the update operation. Okay, update operation to perform in place symmetric difference. Okay, let me update this with the help of update operation. Update. So update operation, we know that do not take any extra set, that will perform the symmetric difference between set 1 and set 2 and store the result back in set 1. Okay, so if I print set 1, I must get the same result 1, 2, 6, 7, this thing. Yeah, 1, 2, 6, 7 I am getting. So symmetric difference update function is used for performing in place symmetric difference operation. Okay, fine. Okay, we can also perform symmetric difference between set and tuple, set and list. Fine. Okay, I am taking some example list and tuple over here to perform that operation. Here we have a set with us, we have a tuple with us, we have a list with us, and now let's perform symmetric difference between set and tuple, set and list. So first set and tuple. Okay, A is the set, so I am storing it into another variable D, A dot symmetric difference with tuple. Okay, and symmetric difference now of the set with the list. List is C. Okay, fine. Just let me print it. Print D and print E. So if I execute it, we find out the difference between this set and tuple. You can see that common elements are 1, 2, 3, so that will go out. What is left? 4, 5, 6. So we are getting 4, 5, 6 over here. And if we are taking the symmetric difference between this set and this list, then common elements are 4, 5, 6. Those will go out. What is left? 1, 2, 3. So we are getting 1, 2, 3 in the output. Fine. Okay, that's it about the symmetric difference. And okay, we have discussed all the operations. We discuss about the symmetric difference operation, we discuss about the difference operation, we discuss about the intersection and union, and we perform various comparison operations, and also we see the containment operation also over here. Fine. Okay, let's go back to the PPT. Oh, that's it for this session. Stay tuned. Meet you in the next class.